So graphing a system of linear inequalities. First, we'll graph this first one. So y equals x plus 5. What is my slope in that case? It's 1, right? Or 1 over 1. And my intercept? 5. So first I'm going to graph 5. I have a slope of 1, so it's a rise of 1 and a run of 1. And notice that it has just a less than symbol in it. So am I going to have a solid dot or a solid line or a dotted line? Solid. Nope. Dotted line. So it's going to be dotted line. It has an equal sign underneath it. Yep, right. Okay, so now I need to determine what side to shade in this case. So I'm going to take a point. Which point would be the easiest one to test? 0, 0. So here's the point I'm going to test is right here. Okay. If I put in 0 for y and 0 for x, 0 plus 5 is 5. So is 0 less than 5? Is that a true statement? Yeah. So I'm going to graph the side where shade the side where 0, 0 is. Okay. Now we want to graph the other line. We have an intercept of 3 and a slope of -1. So I'm going to go up to 3. And my slope is down 1 over 1. Now, do I need a solid line or a dotted line? Solid. So I'm going to graph this now. There. Next part is I need to determine what side of that line to shade. So we'll try 0, 0 again. And I'm going to use red this time. So 0 is less than 0 plus 3. Is that a true statement? Yes. So I'm going to shade this part of the line. Now, the solution set for this is where both shaded regions are together. Okay, so what area is shaded? The top, the bottom, the left, or the right? It's the bottom section, right? So my shaded region here is this triangular area right here. That is the whole solution set for both equations. Okay? Intercept form, not slope-intercept form. This is in standard form. So the easiest way to graph these ones is to find our intercept. So I'm going to take this first one, put 0 in for x. When I do that, I have -3y is greater than or equal to 6. Okay, and also when I divide both sides by a negative, what happens to my sign? My inequality. It flips direction, so it's going to be like this. Okay, so my y is going to be at a -2 on this one, and I need to do the same thing for x. If I cover up my y, 2x equals 6. So x is going to be 3. So if I put a point here, now I can use either a solid or a dash line. Which one I'm going to use? Solid. So here's my solid line. We need to test a point to see what side to shade. I'm going to use purple this time. So if I put 0 in for x and 0 in for y, I'll have 0 is greater than 6. Is that a true statement? No. So that means I'm not going to shade the side where 0, 0 is. I'm going to shade the other side. Okay? Do the same thing for this one. We have 4x plus 3y. If I put in 0 for x, I'll have 3y less than 12 or y less than 4. So I'm going to put a point at 4. And then if I cancel out my y's, I'll have 4x less than 12 or just x less than 3. I'm going to have a point here. Now, do I have a solid line or a dashed line for that one? Dashed. Yep. So there we go. So we can test 0, 0 again for this one. So if I have 4 times 0 plus 3 times 0, that's 0, less than 12, is that a true statement? Yeah, it is a true statement. So I am going to shade this area. So where the purple and the red are together, that is your solution set for this set of equations. Anybody have any questions for me on that one? This problem is out of your book on page 409, and it's an example of how applications are used for inequalities. And this one, it's talking about where deserts, grasslands, and forests occur, and it is based on precipitation and temperature. Okay? So right away, forests can occur if the temperature is greater than 35, and that's true for all three of these situations. Okay? Forests can occur if you have 5 times the temperature minus 7 times the precipitation is less than 70. And then on grasslands, you have another condition that has to happen, and that's this one. 3t minus 35p is less than 140, negative 140. So what they're wanting us to do right now is test to see if A, right here, which happens to be the point 50, 30, test to see if that can be a region where forests occur. Okay? So all we're going to do is put in that point into these two equations because we're testing for forests. Here, t is greater than negative 35. Well, 50 is greater than negative 35 or positive 35, so that's true. So the first condition has been met. We're going to find the second condition. 5t minus 7p is less than 70. We're using this equation now. We put in 50 and 30. And notice that as you go down and solve it, 40 is less than 30. That is true. So that condition has been met. So yes, this satisfies the system for forests. Okay? The next little example here is it says, show that point B is a solution of a system of inequalities for grasslands. Okay? So here's point B. We're going to use the point 60, 20. And which set of equations am I going to use? The first, the second, or the third one? Because I'm testing for what? Testing for grasslands, right? So if I'm testing for grasslands, I need to look at these set of equations. All three of those conditions have to be met. Okay? So first of all, right off the top, if I replace my t with 60, is 60 greater than 35? Yes, so that condition's already met. Okay? Let's replace these ones right here. We'll have 5 times 60 minus 7 times 20 is greater than 70. Well, 5 times 60 is 300 minus 140. Then I have 160. Is 160 greater than 70? Yes, so that condition has been met. And I need to test the last one now as well. So I'm going to put in 3 times 60 minus 35 times 20 is less than or equal to negative 140. So 180 minus 700 is less than negative 140. This would be negative 520. Is negative 520 less than negative 140? Yeah. So this is also, this condition has been met. So this point definitely can be within a grassland region. Okay, and that point is the temperature of 60, the average temperature of 60, and the average precipitation of 20 inches. Okay? Any questions on that one?